Good morning, folks. This is Todd Coburn of Cal Poly Pomona with your Aerospace Structure series. Today we're continuing our study into fasteners, and we're going to focus on the analysis of rivets. So we're going to look at three basic types of rivets: protruding head rivets, flush head rivets, and flush head rivets. Yes, you heard me right. We're going to have rivets that end up with a protruding head and rivets that end up with a flush head. Now we're talking about a protruding head. We're talking about a round or various types of rivet heads that protrude out of the material. The back, the butt end also protrudes. When we talk about a flush head rivet, we're talking about two types of flush head rivet. The first is a machine countersunk flush head, where you machine countersink the sheet and then drop the flush head fastener into that and buck it into place. The other one is a flush head rivet in dimpled or double dimpled sheet, when you actually deform the sheet to make the little pocket for the rivet head. Okay, those are the three types of fasteners we're going to be looking at. This little table here is a table from Brune that basically gives some general rivet dimensions. If you start with the shank diameter, and he's calling that diameter A, the nominal diameter, then you can approximate the bolt head diameter and the rivet head depth, the dimensions B and C, using this table here as a function of twice the diameter, some fraction of the diameter. Okay, before you continue this, or maybe after you're done absorbing this material, if you really want to understand rivets more, these are two good videos. You can flash your camera at those. One of them is kind of on general rivets, kind of made quite a while ago, and the other one is on installing rivets, and this will help you to understand a little more about rivets. Okay, so looking at protruding head rivets now, we're going to look at three strengths for each of these kinds of rivets. We're going to look at the shear strength, we're going to look at the bearing strength, and we're going to look at the tension strength. Now, if you don't know what those things mean, you need to go back to your 3261. I believe it's the fourth lecture where we cover the basic analysis of shear, bearing, tear out, tension for fasteners, net stresses, and things like this. So starting off with the shear strength of protruding head rivets, if we have a protruding head rivet, we will come to this table. This table, you'll notice here on the left, we see what our material is. It's listed different materials. You'll find out as a reference value what the FSU of those materials are. And then you're going to have the diameters of those rivets and what the corresponding strengths are. So for a 7050 T7351 rivet, these are the shear strengths. If you have a 5/32 rivet, your shear strength is 854. If you have a Monel 1/4 inch rivet, your shear strength is 2695. Now, we're going to call this the basic shear strength, and we're going to denote it with an S prime. This is not standard nomenclature. I haven't seen anybody put a prime on rivet strengths, but it's to remind us that actually MMPDS requires us to correct this value or adjust it based on the sheet thicknesses. So we'll start here. We'll get our S prime value from this table, carefully checking what our material is and our diameter. Okay? Another piece of information in this table is this rivet code. Now, the way these rivets are shown on drawings is a lot of times they will use a code, as they did, especially on older drawings. And the code looks something like this. They'll have like a DD rivet, and then they will put like a 5 here. And then they'll have other information down in these brackets. We'll ignore that for now. So DD says, oh, that's a 2024 T31 rivet, and 5 means it's 5/32 diameter, which means our shear strength is 815. We're actually not going to be diving into that much or at all this semester. Beyond that general understanding, I may add more content into our handbook and lectures at a future date. So we start here. If we have a protruding head rivet, we come here for the shear strength. We get the S prime. Then we look for our correction factor. We're going to have two correction factors. One if the rivet is in single shear, and the other if that's in double shear. Once again, if you don't know what these things mean, go back to lecture 4 of Aero 3261, watch that, and then come back here. If your D over T ratio, the diameter over sheet thickness ratio, is greater than 3, then we need to correct the value using this formula here. If the D over T ratio is less than 3, then we'll take that value of 1. Don't ever use a correction that increases the rivet strength. What that basically says is if the rivet diameter is too small or too large relative to the sheet thickness, then the rivet will not develop its full shear strength, and we need to correct the value, okay? Now, if you have rivets in double shear, then we're looking for a D over T ratio exceeding 1.5, and we will use the second equation to adjust it, okay? Once again, never use an adjustment more than 1. So we go up to table 532, get our S prime. We come down and adjust the value if we have a D over T ratio out of the range for the type of shear joint we have. And then we calculate our allowable rivet corrected shear strength as that correction factor times the S prime. That's your allowable rivet strength. Got it? That's how we get the shear strength for rivets. Common student mistake, they don't correct the value. Common student mistake, they correct the value wrong. That's how you do it. Okay, next, bearing strength. When we have a protruding head rivet, we can use this table to get the bearing strength. Basically what we will do, these values, these are called unit bearing strengths. And what that means is this is the bearing strength that we would see if our sheet materials that are attached together have a bearing allowable of 100 KSI. Now most rivets in aluminum, the aluminum has a higher bearing strength than that, so we'll end up factoring that number up. So what we'll do is we'll calculate we'll first come to this table. Let's say we have a 5/32 rivet in 071 sheet. That means our SBRU prime, once again I'm going to use a prime value to say we haven't adjusted it yet from the unit bearing value. It's 1129. Then we will go look up for whatever sheet material we have. We'll look up at our FBRU. We will place that value in the units of KSI, divide it by 100, and then multiply it by our SBRU prime, and that will give us our bearing allowable for the rivet. So for shear strength, we need a basic value that we are going to correct as needed, and for bearing, we will get a unit bearing allowable that we will correct as needed. Got it? All right, that's how it's done. Now, just to kind of set the ground, clear the air a little bit here, we could have actually used our basic bearing formula and estimated the bearing strength as SBRU equals the rivet area times the FBRU of the material. That's completely acceptable. The deal is, the reason this is not used in industry so much is because when you buck a rivet, the diameter expands as it's being compressed, expands into the hole, which means you end up having a larger than the nominal rivet diameter, which means that will give you an overly conservative shear strength. So for our class, now if you actually had the driven rivet diameter and use that, then that would give you an accurate strength. However, for our class 3271, what we will do is use this table of unit bearing strengths adjusted by the equation for the FBRU of the material, and that will give us the most accurate values that we can get easily for these numbers, okay? So we know how to get the shear strength protruding head rivets and the bearing strength. Now we're ready to figure out what is the tension strength. I've been told from the time I was a young pup in industry that you don't show rivets in tension. Sure, okay. What that really means is you really shouldn't put a rivet in a joint that is going to develop any measurable amount of tension. However, there are a lot of times when a rivet may end up picking up incidental or secondary bending that can end up putting a little tension on it. And for this reason, we need some kind of allowables for tension. Now, Brun has a set of values in his text, and that's what I'm reporting here, is values from there. And you'll notice that this table gives protruding head strengths for a certain type of rivet and a certain kind of material. We're going to go ahead and arrow 3271. We will use these values for whatever we find. And in industry, you can do the same. Of course, if you're in industry, what you could do to have a little better number is to start with the values here, and then you can factor that value up or down based on your strength of whatever rivets you have or whatever sheets you have that installed in. Okay, so what we're going to do here, once again, we're going to go and look. First, we're going to find what diameter of rivet we have, and then we'll look at the thickness of the sheet, the thinnest sheet that's attaching it, and that will give us our rivet tension allowable in pounds. Okay, you got that? You'll notice that shear allowable, that was in pounds that we did in the first slide. Our bearing allowable, that was in pounds, and our tension allowable is once again in pounds. Okay, that's how it works. Now, if you only have tension on the rivet, that's kind of unlikely. If you only have tension on the rivet, you can write your margin of safety as the tension on the rivet against the tension strength. However, if you have combined loading, shear and tension on the rivet, as usual will happen, because usually your rivets are going to be designed for being in shear, you may end up picking some incidental tension up, which means if you have tension, you're almost always going to need to use this interaction equation. In order to use that, we will calculate the stress ratios. If you don't remember how to do that, go back to your 3261 handbook, read up on stress ratios. Regardless, here are the stress ratios here. The shear stress ratio is just whatever shear force is in the bolt versus whatever the shear allowable is from that first slide. Our tension stress ratio is whatever tension force is in the bolt divided by the allowable tension from this table. You then take your two shear stress ratios, plug them into your margin of safety equation, plug and chug, bang, you got your margin of safety. Now, you do not compare, you do not combine tension and bearing. Those are completely different planes, areas, and failure modes. You combine shear and tension, okay? But you also still need to check to make sure you're good for bearing. So we'll check for bearing margin of safety as a separate standalone check, not combining it with anything. So if you have a rivet that is in both tension and shear, you'll get your shear allowable, you'll get your bearing allowable, you get your tension allowable. You can check your bearing margin of safety directly, and then you'll write the stress ratios for tension and for shear, combine them in this margin of safety equation, and that reports how close you are to being good or not good. Okay? All right. That's how it works. So that's how we handle protruding head rivets. If we have flush head rivets, we're now going to have two approaches, one for flush heads in machine countersunk sheet and one for flush heads in dimpled sheet. Let's take a look at that. Okay? This is the table for allowables when we have a flush head fastener in machine countersunk sheet. Now we can have it where they flush one side or where they have a flush head fastener and then they buck it and place into another machine countersunk hole. Okay, so typically what we would do on the protruding head side, you can analyze it as if it's a protruding head rivet. On the flush head side, you analyze it like it's a flush head rivet. In this class, 3271, we're not going to do anything that complicated, but you folks in industry, that's how you would handle that. Okay, so we're going to notice a number of things here. So once again, this table is for specific rivet materials and specific sheet materials. There's the rivet materials, here are the sheet materials, okay? Once again, our shear and bearing strengths are in pounds. We're going to start by finding what kind of rivet. Let's say we have a 2117T3 rivet. That means we're in this part of the table. We then get our diameter. Let's say we have a 3/16 rivet. And then what we can do is get our strength as a function of our sheet thickness. If we have 050 sheet, that means our allowable is 6 to 8. If we have 090 sheet, then our allowable is 795. If we have anything over 0.125, then we have this number here, and that happens to be our shear strength. What happens is our shear strength for this 3/16 rivet is 862. That's already corrected for any values. Remember, that correction is only as your sheet is too thin for your head. So when you top out on these tables, first it's bearing critical, and then it becomes shear critical, and you're already beyond the cutoff of that correction factor. So if your rivet shear strength is 862, what this means is you're going to have the full shear strength of the rivet for any sheet that's thicker than 125. If you're 125 or thinner, then you will be a lesser value because it's limited by bearing. And if we get a value between, like let's say we have an 075 sheet, then we will need to interpolate between these two values to get the correct strength. Okay? So you see here that we get everything we need, both shear and bearing, from this single table. You just need to take care to read it correctly. And even though this is shown for a number of sheets here, we will use it in Aero 3271 for any sheet we find. Now, if you're out there in industry, what you should do is go get MMPDS, look up your rivet in I think it's chapter 8, where you can look for your specific rivet. If you can't find it, then you can use this as an approximate value. You can do ratios of the relative strengths of the materials to try and adjust the number to be more meaningful for your application. Or better yet, go do some testing to get your own values. Now, if we have a flush head rivet in machine countersunk sheet loaded in tension, we will handle it in a similar manner that we did to the protruding heads, only we get a different table, and here's that table. Okay, we're going to come here. This is for ultimate tension strength of flush head rivets and machine countersunk sheet. Once again, we're going to go and find first our diameter and then our sheet thickness. And if we had a 3/16 and 091, we'd have a 912. If you have 3/16 and 063, you will have to interpolate between the values here and here. Got it? Okay. Once again, as with protruding head rivets, if you have shear and tension, you're going to need to write the margin of the two stress ratios and then combine them and check your bearing allowable separately. All right, one more to go. Let's say we have a flush head rivet in dimpled, single or double dimpled sheets. Single dimpled means you have one of the sheets that are dimpled. Double dimpled means they've both been worked so that that head drops in place. You're going to come to this table. It's very similar to the last table. We got a little more information going on here. Once again, you got the rivet material here, here, and here. And then you've got, for whatever rivet material, let's say we have a 2117, you then will go and figure out, okay, what kind of sheet material do we have? Let's say we have 2024 T3. Let's say we have a 3/16 rivet. That means we're here. If we have 063 sheet, then our allowable is 1012. If we have 090 sheet, our allowable is 1098. And our shear strength happens to be 1098. So for anything above 0.09, our strength is 1098 and it's shear critical. Anything below 090 thick, we have whatever allowable is shown, and those are bearing critical because the shear allowable hasn't changed. It's still stronger, but the critical one where failure would occur is the bearing. Now you shouldn't, what this says is this, for this 3/16 fastener, you shouldn't use it in sheets thinner than 032. Okay, so up above we just use the shear value. Anything above the last value, you can just imagine those are all the shear value. Anything below the first value, we're going to assume that it's not acceptable. And when I say below the first value, I mean where the sheet thickness is below, which means it's actually located above the first value. And when I say it's below, what I mean is it's after the last value. Okay? So what is the shear strength of a 2017 T3 flush head rivet and dimpled sheet if it's 5/32. You'd say, okay, we've got 2017 T3 and 2024 T83, 5/32, and if we want the shear strength, it's this. If we want the bearing strength, you got to say, well, what thickness are we talking about? Let's say we're talking 050. That means we come here, and it's 864. Got it? That's how you do that. Now for tension strength, we're going to come to this table, and once again, we're going to have the same story with interaction. So we'll see, we're going to go and just grab what is our diameter, what is our sheet thickness, and that gives us our allowable. And we will combine shear and tension. So that is how we handle rivets for strength in aerospace. We need the shear allowable, the bearing allowable, and sometimes the tension allowable. And for actually using them for margins of safety and for other checks, you can go back to your 3261 lecture 4 and remind yourself how to analyze shear, bearing, and that kind of thing. Got it? Enjoy.